Questions? No? Everybody's good? All right, well, we're still recording, so we're gonna do that for a little bit and get through this. This is where we left off. We left off here on page 30. We were talking about sum and difference formulas for tangent. So we covered cosine, we covered sine. We said that just everything tangent does is a little harder because it's not explicitly on the unit circle, right? It's y over x. So you have to make a little fraction and then put it in. So it's a little harder. Also, the formulas are actually fractions. So that can be kind of an issue. All right. Excuse me. So I think I already told you that this one was my math lab number 3. I'm not sure if I told you that or not. Okay, no, I'm seeing no. So this formula using a drop box is what they're going to want for my math lab 3. Okay. And then we're ready to use sum or difference for these two. Sorry, I was eating almonds and I drank all my drink. I guess I could drink that Dasani. I don't know where it came from. Okay. So here we go. Before we jump right in, we talked about the fact that I mentioned that with tangent, because you do have some options in your angles, you want to pick the easiest path, right? So basically, there are 3 angles, right? There's the 30-degree type, the 45-degree type, the 60-degree type, and then they repeat around the unit circle. So let's just look at tangent for each of these situations so that we can kind of get an idea of maybe a better choice to use, right? Okay, so tangent of 45, always a winner because y over x is going to be 1. And even if you're in one of these other quadrants, the hardest it's going to get is -1, right? So any kind of 45-degree situation is going to be a good situation for us with tangent. That's a great choice if you can fit 45 into the situation. Okay, now let's look at the other two. All right, 30-degree situation puts 1/2 over √3/2. All right, the 2's are going to cancel, and what's going to happen in that situation is you're going to end up with 1 over the √3. Okay, well, if you're using a 30-degree and you have 1 over the √3, you have to rationalize that. And now you're dealing with a fraction. You're dealing with √3/3. This is the most difficult route you could take. It's not hard, you guys can do it, but it's just a little more taxing on the brain. All right, let's look at the tan 60 situation. The other situation would be √3/2 over 1/2. Your 2's cancel, and what do you get? √3/1, which is just √3. Well, hey, that's not bad. So if I were you, my advice is to try to stick with the 60s and the 45s, a combination of those. If you can't help it and you can't think of any, this is not the end of the world, okay? I'm going to do this first one for you 2 different ways, just to show you what I think is an easier path and what would be worst case scenario, because it's not that bad. And then from then on, we'll kind of stick with the 45s and 60s, just because why would you choose to have a denominator, a fraction in a fraction? Then you're getting into complex territory. It's just a little harder, that's all. Okay, so let's look at tan of 101 degrees. So you can do this a lot of different ways. You could do a big angle minus a small angle, or you can do 2 small angles added together. So that would be the easiest route. So let's do it first. So what if I said, okay, I'm going to do tan. Is that light on? Maybe I need to write harder. Not surely really showing up on my screen here. Okay, tan of, let's see, I could do 60 and 45. You could do 45 and 60, right? It doesn't really matter what order you put them in, but these add up to be 105, and they're the easiest ones in my opinion. So let's look, this would be the easiest route. Let's see what that turns into. Okay, here's alpha. the ugly alpha, but there's alpha, there's beta. Let me lower this a little bit more, see if that helps that crew. Okay. All right, here we go. Since I'm adding, I'm up here in this situation here. So I'm going to have the tangent of alpha, which is 60, plus the tangent of beta, which is 45, all over 1 minus tan of 60 times the tan of 45. Okay, there we go. Everybody agree with that? That's what that means. That's what we ended up with. So now we're just going to use these values that we already created and we're going to plug it in for those. Okay. All right. So in the numerator, tangent of 60 is square root of 3. Here's my plus. Tangent of 45 is 1. There's my numerator. I don't even need this gigantic line. Okay. Then in the bottom, I have 1 minus. Okay. Tan of 60 is root of 3. Tan of 45 is 1. Okay. So this ends up as the square root of 3 plus 1 over 1 minus the square root of 3. Okay, I can't leave it like this. I'm going to have to rationalize it. Now, this is where the heavy-duty algebra comes in, because if all I had in the bottom was the square root of 3, you guys would multiply top and bottom by square root of 3 and be great, right? But I have 2 terms down there. So I have to use a conjugate. Everybody remember the conjugate situation? So what would be the conjugate of this denominator? I'm going to have to multiply the top and bottom by it. Well, all we're going to do is change the sign on the root. You change the sign on the problem child. The 1's fine. We're going to change the sign on the square root. So the conjugate of 1 minus square root of 3 is 1 plus square root of 3. What that does is it completely eliminates a root in the bottom. Okay, so if you have 2 terms and one of them's a root, then you just use the opposite middle sign. Okay, the sign that's on the root. All right, well, if we seal everybody off so we don't lose them, we have a big FOIL situation. Okay, we can do this. Let's FOIL. So we're going to have square root of 3 times 1. All right. Then we're going to have, oh, you know what I'm going to do? Well, that's not a big deal. Okay. Then I'm 1. Okay. Then I'm going to have square root of 3 times square root of 3. What's that? 3, right? Okay. Then I'm going to have 1 times 1. And then I'm going to have 1 times the square root of 3. So there's my top. Okay. Let's look at what happens using the conjugate in the bottom. I'm going to have 1, a positive square root of 3, a negative square root of 3, minus 3. Okay, everybody okay with that? All right, these are going to cancel. That was the point of the conjugate. Okay, let's combine this stuff up here. All right, so really good math manner says you put the regular term first. So let's do the 3 plus 1, that would be a 4. Plus, what's root of 3 plus root of 3? 2 root of 3, right? There's 2 of those guys. All over. All right, what do I have in the bottom? -2. Okay, so those of you that took college algebra with me, we have this little fancy schmancy triangle, right? When you get a triangle, it means you can divide every point of the triangle by the same number to reduce it. So I can take the little magic triangle there because every single point has a number that can be reduced. I'm going to divide every point by -2. Okay, so every point gets divided by -2. I chose -2 because that was my denominator, and I'm trying to get rid of that, reduce as much as I can. So 4 divided by -2 is -2. 2 divided by -2 is -1. I still have root of 3. And then at the bottom, I just get a 1. And there's my final answer when I'm all said and done. How's that look? That's what I should come up with. Okay, so that was, I'm using air quotes here, the easier way to deal with it, okay? Because we didn't choose this dude here. Now, what if you had to? I'm just going to do this the one time because I don't want you to be scared of a 30 degree, but I just want you to see what would happen if you did that. Okay, so you don't have to write this down unless you want to, but okay, so let's say instead of the 60 plus 45, let's choose like, how about 135 minus 30? Let's say you just had a brain freeze and that's the only thing you could come up with. Okay, all right. This is a derivative of the 45 degree angle, right? This is a multiple of him because it has the 5 in the bottom. Okay, here we go. Here's our alpha. Here's our beta. So we're going to take tan of 135 plus, nope, wrong one, that's minus tan of 30, okay, all over 1 plus tan of 135 times tan of 30, okay? All right, well, we go to our unit circle. I'm looking for 135. That's right here, second quadrant. So when I form tangent with y over x, I'm going to get a -1 this time, okay? So -1 minus tan of 30, we already worked out was this root of 3 over 3 situation, okay? Then I'm going to have 1 plus a -1 times a root of 3 over 3. And there we go. Okay. Let's clean this up. All right, new issue has arisen in the numerator. I have 2 terms and I need to make it into 1. Okay, it would be really nice if it was all into 1. So what could I change this -1 to? Yeah, like -3 over 3. That would work, right? If I did that, does everybody see that? Okay, so then that would be -3 minus a root of 3 over 3. That would be my new numerator if I did that. I just did that all in one step. Okay, down here in the bottom, what I've got is 1 minus root of 3 over 3. Okay, well, I just chose to put it all in one step, so I'm going to do this. Okay, so this is going to be 3 minus root of 3 over 3. Okay, everybody with me so far? Okay. Now, does anyone see a way I can reduce this guy? Do you remember? Now you can do keep, change, flip, but what do you do if you have a fraction in the top and a fraction in the bottom and they have the same denominator? Do you remember what you can do to that denominator? You can cancel it, right? So I can cancel that, and that's going to give me a more normal situation. Okay, there we go. Say that one more time, Sam.
-3 on top is like.
Oh, this guy to here? You mean?
No, the one farthest to the right. Would that just be -1? Or you have to do more to it?
I can't figure it out what you're saying.
Okay,
so you
so-
just cancel the two.
Yeah, but it's the same.
Oh, right here?
Yeah.
Oh, no, you can't do that. Okay.
Why?
I know Abby tried to do that last night. She came over and she's like, Mom, I can't figure out this in my math lab. I was like, where did you see that? Okay. No, because they're 2 different terms. Okay, thank you. All right, sorry. So let's say you had this and this. Let's say this was the fraction, okay? All right, let's say this was it. Then you could cancel this and get a -1. Well, these would cancel too, but they can cancel if they're being multiplied. You can cancel like that for multiplication and division. The problem with this is these guys are being added and subtracted to someone else. So the only way you can cancel in this situation is if you can divide it out of every single term. See, the reason we could cancel here is because I could divide it out of every single term. But here, I can't divide a 3 out of every single term because I'm not allowed under here. Does that make sense? So if you have 2 separate terms on the top and 2 separate terms on the bottom, you can't just go through. I'm trying to think of what she did last night. It was like some kind of, I called it Mickey Mouse math and she got mad at me. What were you doing? I also may have gotten really mad and used an inappropriate word I won't say in front of you guys, but I'll just pretend I said, what is that Mickey Mouse math? And then we'll go from there. but it looked kind of like she was doing something like this, and she canceled these out and was like, look, mom, and now it's like 1/3, I'm done. I'm like, no. So no, you can't do that. If you're adding and subtracting, okay, you can't do that.
Is it because you need something there because you're subtracting, so you need like a placeholder, I guess?
Well, yeah, but these are like, they're like in a relationship, and you can't have, and he's in a relationship, and you can't just like break free of that and put something up there and start, you can't just start canceling. When you have addition and subtraction, they are really difficult to deal with. Like anything they do, they're difficult. With fractions, they have to have the same denominator. With radicals, they have to have the same radicand. When you have addition and subtraction, you just can't go start canceling things. You can if they're multiplied together, but you can't if there's an addition or subtraction. Does that help a little bit? I'm really glad you brought that up because I couldn't, yeah. All right.
Even if you multiply the denominator by -1, it'd be -3 plus square root.
Yes, you can do that. You could do that. If you want to, Summer said, what if you wanted to multiply by like a -1? You could do that. And then this would be like 3 plus √3 in the top. Now you'd still have this guy in the bottom.
Well, no, I think the same was like, you just cancel it out and it would be -1.
Oh, these, because they're so similar.
But the numerator would have to be -3 plus.
Oh, okay. Now I'm getting it. See, sometimes I just can't figure out what you people are saying. Okay, now I gotcha. Okay, are you saying because these look awfully similar, it looks like they only have a -1 multiplied through them? Okay, so if I pulled a -1 out of the top and I divided both terms by -1, I'd get 3 plus √3. But my denominator is still not the same. So I still can't cancel it. And I can't break them up and cancel single terms. So there's no way, these are not the same in any way. They look really close, but they're not.
But if there was no negative at the top, you cancel them out.
Well, yeah, if it was this, if it was 3 minus √3 and 3 minus √3, yeah, because they're little packets. They're little perfect, every single term cancels. It's either all or nothing.
But like if we do like a -2/2.
That's -1. Yeah, but these are just, they're not the same. There's no way to make them the same. Yeah.
But let's say there's no radical, and let's say it was x.
Okay, so let's say -3 minus x over 3 minus x, like that? Okay, well, these aren't the same though. So if I pull out a -1, they're still not the same.
Oh, okay.
You know what I mean? They're still not the same. Okay, is that all right?
Yeah, I
Yeah,
got it now.
okay, all right. Sorry, we went down a crazy rabbit hole. Okay.
It had to be done.
It had to be done, but we did it. We're just gonna have to start over here. You can see my coffee stains. Okay, let me think. So this is -3 minus √3 over, okay, sorry. Sometimes it takes me a minute to figure out what you're asking, but I'm so glad when you ask. So is everyone okay if we stay there? Keep going? Okay, so we have to get that radical out of the bottom. So we're gonna multiply by conjugate of the bottom. Conjugate of the bottom is 3 plus √3. Okay, so now we're 3 plus √3. We're foiling. We're going to get -9 minus 3 √3 minus 3 √3 minus 3. Okay. All right, down here we're going to get 9 plus 3 √3 minus 3 √3. Those are going to cancel, minus 3. Okay, I know they all look so similar and you just want to cancel the whole thing, but there's like one sign that's wrong. So you can't cancel it. There's no way to fix the one sign. Okay, -9 minus 3, we have a -12 minus 6 √3 in the top. Okay, bottom we have a 6. Okay, now if we check every term involved, which happens to form the magic triangle, okay, we can divide every point of the triangle by the same number, which in this case would be 6. And we get -2 minus root of 3. And that's the same thing we got when we did it the other way. Okay, so a lot of ways you can do it. A lot of ways you can do it, but I recommend you kind of try to stick with the 45 and the 60 if you can. Sound all right? Okay. All right. I feel like I've scared you so bad with the 30. No one's ever going to use 30 again. Okay. No. Okay. All right. Let's look at 15. Okay. So if we're only going to stick with 60s and 45s, how are we going to get 15? What do we think? There you go. Yeah. How about 60 minus 45? Ta-da. Okay. Pretty close. So here's our alpha. Here's our beta. Okay. We follow our subtraction way up here at the top. We're going to do tan of 60 minus tan of 45 over 1 plus tan of 60 tan of 45. Okay, these are awfully similar formulas. You see that? So what do you think your answer is going to be, considering this was 60 plus 45 and this was 60 minus 45? It's going to be pretty darn close to this, right? All the answers tend to look the same. We kind of talked about that before. So just be aware of that. It's going to be pretty similar. It's just going to be like one sign off. So, okay, here we go. Tan of 60 is root of 3 minus tan of 45 is 1. Here's 1 plus tan of 60 is root of 3. Tan of 45 is 1. We're kind of right back where we were. See that? We're like so close, but there's nothing you can do. Oh yeah, where'd you go?
Just to make sure.
Yes.
So so right here, when it says like 60 minus 45,
Uh-huh.
and you look up, you have to make sure it lines with this, and that's the one that you use.
Exactly. Exactly. So this was 60 plus. So we line it up with the plus, and we're going to use this one. And this one's the minus. You use the minus. Yep, exactly. And that's how you know what to put where and what sign. Good. Okay. Now we want to get that radical out of here. So hopefully you are comfortable knowing you're going to multiply by the conjugate, right? There you go. All right. So now we're going to get root of 3 minus a plain 3 minus a 1 plus a root of 3. Okay. Your denominator is going to be 1. Now you can save yourself some math here. You know that this is going to cancel out the middle term. So you know this is going to be negative root of 3 and this is going to be positive root of 3 and they're going to just cross out. So you could just multiply root of 3 times negative root of 3 and get minus 1. Okay. All right. Sorry, daughter's being weird. Okay. Negative 3 minus 1 minus 4 plus 2 root of 3. And then the bottom, we're going to have negative 2. Okay. Magic triangle. Okay. You didn't. So if every single term can be divided by the same number, let's do it. And since the bottom is a negative, let's just multiply everybody by a negative 2. That's going to be a positive 2 minus root of 3, 1 in the bottom. There's my answer. I mean, that is really close to the one right above it, right? They all are just like right there in the family, like one sign off. Okay. Sound like a plan? Okay, I feel like you guys can do that. So that was, those two were my Math Lab 6. No, wait a minute. 6. Sorry, my Math Lab 6 kind of deals with both of those. Okay. All righty. Am I missing something on here? It goes right on to there, and then that's it. All right. That's strange. I thought there was another one. but I guess I made that up. Okay, so there's no C. We go right on to this. Does this sound good? Okay. All right. So last two. These are a little strange, but they're easy. So we're going to think about what they've given us. Okay, we're going to go from there. So here's what we're going to do now. We are still going to find sum and difference formulas. So if you look at A, B, and C, this is what they want you to do. They want you to find the difference formula for cosine, given this information up here. Sum for tangent, given this up here. Difference of sine, given this up here. But this up here looks weird. Okay, so here's the deal. There's a little tiny semicolon here. So if you want to, this is the information that goes here. This is the information that goes here. It's two separate pieces of information. So don't get overloaded by thinking they all go together. Okay. All right. Now, here's what they're telling you. They're not giving you the angle alpha, and they're not giving you the angle beta. So you can't come up with two angles to add to get alpha because you don't know what alpha is. And you can't come up with two angles to give you beta because you don't know what beta is. So you're kind of having to do your detective work and sneak in the back door. We could do this. We don't even care what those angles are. Because first of all, this tells us that the alpha angle is located where? What quadrant? Between 0 and pi over 2. Quadrant 1. That's going to be super duper helpful. Okay. Then we're told, all right, everything's in quadrant 1 for alpha, that sine of alpha is 7 over 25. Okay. Sine is y over r. All right. So we are going to figure out everything we need to know about alpha without ever knowing alpha. Okay. Same thing with beta. This tells us beta is between negative pi over 2, that's down here, and 0. What quadrant is that? That's 4, right? Okay, that's going to be helpful. And it gives us cosine beta, which is going to be x over r. Okay, we can do this. Let's make a little chart. Okay. Let's put all our alpha information over here, and let's put all our beta information over here. Now, when I say information, there are three things, three little number values that will give you every trig function in the whole wide world. X, Y, and R. We need them for alpha, and we're going to need them for beta. Okay, so let's do alpha first. Alpha's in quadrant 1, which means X, Y, and R are all going to be positive. Cool. Okay. 7 is Y. R is 25. How am I going to find X? Pythagorean, right? When in doubt, Pythagorean. Okay. So here we go. So for alpha, this is my alpha Pythagorean. I don't know X squared, but Y squared is 49. Oh, 25 squared. That is that 125? No. What's 25 times 25? I don't have that here.
Yes.
Thank you, dear. Okay. Subtract 49, x squared is 576. I had that. Okay. Now we're going to take the square root. Now remember, that gives us plus and minus, but we only want the plus because it said quadrant 1. Okay, that gives us a nice little 24. We can make any trig function that we need now for alpha. We don't even need to know its value. Okay, let's do the same thing for beta. Now beta is in quadrant 4, so we need to be careful. R is always positive, but who's negative in quadrant 4, X or Y? Y, right? Y is negative. So go ahead and put that in there so you don't get that confused. Okay, now this one's ugly. All right, we got to get into ugly territory, but here we go. R is 89. X is 8 times the square root of 89. That's not pretty. He's been rationalized at some point. But anyway, that's all right. Okay, now we need Y. So let's do a beta Pythagorean. Okay, so we're going to have 8 square root of 89. We're going to have to square that. We'll come back to that in a minute. Plus Y squared equals 89 squared. Okay, so don't be scared of this. You can put this right into your calculator. Parenthesis, 8 square root of 89, close your parenthesis, square, and you're going to get the answer. Or if you want to think about it, you're squaring both pieces. So you're going to have 64 times 89, because the square root of 89 squared is just 89. Okay, so you can play around with that. What you're going to end up with is y squared equals 2,225. All right, we got to take the square root of both sides. You get a positive and a negative. Which one do we want? The negative, because we're quadrant 4. Now here's some algebra skills. Okay, so square root of 2,225 is not perfect. So that's not going to work out for you. You're going to have to come up with the reduced radical for that. So you can factor tree him out, or you can just do what most students do, which is put him in your calculator and start dividing by perfect squares till you find one that comes out nicely, right? So if I divide him by 4, he's still a decimal. Divide him by 9, he's still a decimal. Divide him by 16, he's still a decimal. Divide him by 25, and suddenly he's 89. So 25 times 89 gives you 2,225. Well, what's the square root of 25? And you're left with good old 89 in there. So that's actually your y. Okay. All right. If you need help with how to find those or factor tree those out or come up with that, I'm happy to help you. I don't really want to take up class doing it, but I'm happy to help you do it because that's really easy. You need to have that skill. I don't mind at all. Okay. All right. Now that we have everybody, let's just plug them in. Okay. Cosine of alpha minus beta. So we're going to go back to our formulas from before. It turns out this is cosine alpha, cosine beta, plus sine alpha, sine beta. That's the formula when I go back and look it up. Okay. Now let's think about what cosine means. This means I need x over r for alpha times x over r for beta. Then I'm plus y over r for alpha times y over r for beta. Right? That's what that really means. And I have all those right here. So I'm going to go to my alpha column and I need x over r. I'm going to multiply that by the x over r from the beta column. Okay, that's 8 root of 89 over 89. Okay, plus. Now I'm on to sine. So I go to my alpha column. Okay, and I'm going to do y over r from the alpha column. Sine beta, I'm going to do y over r from the beta column. And there we go. Okay. Is everybody all right with that? How we came up with that? So we made the little chart. We used Pythagorean. We got all the x, y, r's. And now we just plugged them back in based on the definition of sine and cosine. Okay. Now we have to clean it up. Okay. Everybody good so far? That was the trig part. Trig part's over. This is just algebra. Okay. So I'm going to multiply these together. Remember, I got to leave square root of 89 alone, right? Okay. So 24 times 8 gives me 192 root of 89. 25 times 89 is, that was our good old 2,225. Now I have a negative over here for this. So it's going to end up making this a minus. Okay. 7 times 5 is 35 root of 89 over 25 times 89 is the good old 2,225 again. Okay, here we go. When we subtract fractions, what do we do with their denominators? Yeah, we leave them alone. Okay, so let's think about this. These are like terms because they both have the same root. They have the same radicand. So 192 root of 89 minus 35 root of 89 is going to be 157 root of 89. Could it be any uglier? Well, yeah, it's going to get uglier. But in the meantime, you can try everything you can to reduce these two, to divide these two, but there's nothing that comes out. You're done. Okay, that's your answer. You have to be pretty darn confident to type something like that into my math lab, right? Because you look at that and you're like, I know I'm wrong. but that's it. Okay. Everybody okay with that? All right, let's try tangent then. Okay, so I have a sum here. So I'm going to go back to my formulas. I'm going to find the sum of tangent formula, which is going to be tan of alpha plus tan of beta all over 1 minus tan alpha tan beta. Okay. All right. Now remember, tangent is y over x. So I need y over x from alpha plus y over x from beta in my numerator. Okay, let's get that. So I go up to alpha up here. Y over x is 7 over 24 plus, I go over to beta, y over x is negative 5 root of 89 over 8 root of 89. Okay, don't panic. What's going to cancel out there? Root of 89. So that's going to end up being a little nicer than you might have thought. Okay, let's do the denominator now. 1 minus, okay, I need y over x from alpha, that's 7/24, times y over x from beta, that's the ugly negative 5 root of 89 over 8 root of 89. Okay. Whew. All right, are we good? Yeah, as good as you're going to get. Okay, here we go. We're not going to panic. Let's look at our numerator first. In our numerator, I'm going to have 7/24 minus, because this is a negative, and then these are going to cancel, 5/8. Okay, that's not terrible, right? I'm going to need a common denominator. I'm going to have to go through all that stuff, but that's not horrible. Okay, down here, I'm going to have 1 minus 7/24. Look what else cancels. Oh, and there's a negative, so this is actually going to be a plus. Sorry, guys. 5/8. Okay, I just moved his negative over to here. So minus a negative would be positive. Everybody okay with that so far? That was really kind of nice. Those root of 89s left. Okay, now we need a common denominator for the top. Okay, well, they'll both divide into 24. So let's use 24. Okay, 7/24 is fine. But let's multiply this guy, top and bottom, by 3. That's going to be minus 15/24. Okay, we can combine him. Down here, I'm going to have 1 plus. I'm going to multiply the tops, that's 35, over 24 times 8, which is 192. Okay, this is why you got to take college algebra before you get into trig. It's not the trig that's hard, it's this algebra. That's just a pain in the butt, right? Okay, all right, let's combine the tops. All right, we're going to leave a denominator at 24. All right, 7 minus 15, negative 8. Okay, we can actually reduce that to negative 1/3 to make our calculations a little nicer. We'll do that in the next step. Okay, what about down here? I need one solid fraction. So what can I change this 1 into? Good, 192 over 192. How about that? And then I'll have 192 plus 35, 227. Okay, I need another piece of paper. I'm going to steal this one. Okay, there we go. Okay, now I'm going to rewrite that top as negative 1/3 just because it's going to look a little nicer. Everybody okay with that? All right, now I have this crazy complex fraction. The denominators they aren't the same, so I can't cancel them, but I can do this. How do you handle a situation like that? Keep, change, flip. Keep, change, flip. So I'm going to keep, I'm going to change, I'm going to flip. Ta-da. Okay, we can do that. All right, now you may or may not see that they have a common denominator at this, I mean, not a common denominator, a common factor at this point that you could cancel out a 3 here. I can divide both of these by 3 and reduce this. If you don't see it, it's not a big deal. You can wait till the end, okay? So if I keep going, I'm gonna get, if I just multiply straight across, I'm gonna get negative 192 over, I don't know what 3 times 227 is, because I reduced. Say that again? 681, thank you. Okay, all right, it's always a good idea to check and see if anything can be pulled out. You can reduce this if you divide top and bottom by 3. And you're gonna get negative 64 over 227. And that's the end. Okay, a lot of algebra in these. Yeah, okay, we're gonna do one more of these. And then the next one, we're just gonna set them up because I think you get the picture. Okay, all right, we okay with that one? I know you don't love it, but you can do it. Not many. Okay, let's try this one here. This one's tiny. He's not going to take up the rest of the paper. He's pretty good if you can still fit him in. All right, so alpha minus beta for sine. If you go look up your sine, difference of sine formula, this is what you get. Okay. All right, so again, we're still doing all this stuff from that little alpha beta chart we made way up high. Okay, so this means I want to go to the alpha beta chart and I want y over r. Okay, that is 7 over 25. All right, cosine beta means go to the beta chart and find x over r. Okay. All right, cosine alpha means go to the alpha chart, x over r. Okay. Sine beta, go to the beta chart, y over r. Okay, there we go. Yes.
What is this math used for?
Well,
No,
did-
like seriously.
no,
like,
seriously, did you see, I was gonna tell you, did you see yesterday where they landed the rover on Mars in the exact spot down to the inch? This is how we got men on the moon. Geometry and trig.
So this
Yes.
goes to
Yeah.
rocket science.
This is rocket science. This is rocket science. You can't say, well, it's not rocket science. It's totally rocket science. Okay, yes, all right. Okay. Maybe one of these like A or C. I can't really remember because I only teach trig once a year and I can't remember the test. I don't teach it year round. No, you won't have a whole page 31. No, it'll be tinier. Okay. All right, so here we go. We're going to multiply these together. Okay. 7 times 8, 56, root of 89. 25 times 89 is 2,225. Okay. Now this is going to be a plus because you have minus and negative. All right. 24 times 5 is what? Yeah. I don't know. Somebody's got to help me out on that. What's the 24 times 5? Thank you. All right. Root of 89 over 2,225. Okay. And then finally, there's our denominator. We have a root of 89. 56 plus 120 is going to be 176. Okay. And I didn't even check to see if you could reduce it. I just circled it and called it a day. Okay. All right. Everybody okay with that? All right. You sure? All right. Now we're not going to do all 4 of these here because you'd be here the rest of your life. We'd never get to 7, 6. So let's just talk about the next page a little bit. Can we do that? Okay. All right. So on the next page, the very last example here, it's still the same situation where we don't know alpha and we don't know beta. Okay. But we have information. And so when you have the information, you're going to make the chart and you're going to write your X, Y, R for alpha, and you're going to write your X, Y, R for beta. And then you are going to fill in every single one of these and you'll be good. Okay. So let's do A and let's do D together because I think B and C will be fine. My work is under content. I'll give you the answers now, just in case you need them, but I don't think we need to go and do all 4 because I think it's a plug and chug kind of thing. And the algebra is easy on these 2. They're not beasts like the other one. Okay, so let's go ahead and figure out what we got going on. So remember, there's 2 separate pieces of information here. It's not like one giant thing. Okay, we got to figure out, first of all, what quadrant is alpha in? Because they've given us negative values. So alpha is going to be in negative 3 pi over 2. All right, normally positive 3 pi over 2 is straight down, right? It's like 1, 2, 3. It's like 3/4 of the way around. So if I'm negative 3 pi over 2, I'm 1, 2, 3. I'm the opposite, right? I'm almost the complete opposite. So this little positive y-axis is negative root of 3 over 2. Does that make sense? We just went that way. Okay, so this is one barrier. Then this says negative pi. Okay, well, this is positive pi. 1, 2. Okay, where would negative pi be? 1, 2. It's the same thing. Pi and negative pi are the same thing, right? Because it's just half the circle. So I'm between here and here. This is alpha. So I'm quadrant 2. Okay, that's important because x is negative in quadrant 2. So I got to be careful. All right, then they give me sign. So I have y and I have r. Okay, so if I make my little chart for alpha and beta, I've got x, y is 3, r is 5. I'm in quadrant 2, so I'm going to go ahead and put in a negative for x, just so I don't forget. Okay, now for alpha, let's see. X squared plus 3 squared, that's 9, equals 5 squared, that's 25. Okay, 25 minus 9, it's a nice 16. Square root of both sides is 4, but we are going to have a negative 4. There we go. We can make anything we want from alpha. All right, now we have to do beta. Okay, his placement's a little easier because we're not talking about negative quadrants. So we're from pi over 2 to pi. What quadrant are we in? 2, same one, right? Same quadrant. Okay, so we know x is going to be negative. We want to find r and y. Okay, they give us tangent. So tangent is y over x. Okay, so y is 1, x is square root of 3. Now, it's negative. We wouldn't have known who the negative was supposed to go with, except that because it's quadrant 2, we know it has to go with x. Does that make sense? Okay, now let's find his Pythagorean. So we're going to square negative root of 3. We're going to square 1, and there's r squared. What's the square of negative root of 3? 3, right? Plus 1. Okay, so this is a 4. Take the square root of both sides. Is the r positive or negative? Positive because it's a distance. Your r is always positive. Okay, now we have all of our values that we need. We have everything. Sound good? Okay, let's do A together just to make sure we're comfortable with this algebra. And then B and C you'll be great on. I don't think we need to worry about it. Okay, so sine of alpha minus beta, this is the plus version. So if you go back and look at that formula, it's sine alpha cosine beta plus cosine alpha sine beta. Okay. And then we're just going to use our little chart. So we're going to go to the alpha chart and we're going to do y over r. It's 3/5. We're going to use the beta chart and we're going to do x over r. Okay. Now we're going to go back to alpha and do x over r. And then we're going to go to beta and do y over r. Okay. Everybody good with where we got those? Okay, here we go. We're going to have a negative 3 root of 3 over 10 minus a 4 over 10. Okay. The 10 in the bottom stays. You can write it exactly like you see it. There's nothing wrong with minus 3 root of 3 minus 4. But if you really want to just be a stickler for it, you can put the, you know, the constant in the front that doesn't have the radical, but it doesn't matter. I'll take it. My math lab will take it. It's not a big deal. Okay, there you go. Sound good? Nothing we can do. I can reduce 4 and 10, but I can't make my magic triangle. So there's nothing I can do. Don't separate them. Trig likes chunks. Okay, leave it as a chunk. If you can't do the whole chunk, leave it alone. Okay, so let me go ahead and tell you that B, just in case you want to practice, you certainly don't have to do it, is going to be negative 3 plus 4 root of 3 over 10. And C is 4 minus 3 root of 3 over 10. See, they all tend to have the same numbers once you get going, and they're just in different places with different signs. They keep it in the family. But I want to do D because I feel like the tangents you need a little more practice on. Let's the last one. And then we're going to talk about 7, 6 and 7. Yeah, 7, 6. Okay. Okay. So let's look at D. All right, D is the difference of tangent. Okay, so if you write out your difference of tangent, that one is going to be tan alpha minus tan beta all over 1 plus tan alpha tan beta. Okay. I had this worked on a piece of paper. What did I do with it? Was it this one? Yeah. Okay. So here we go. I'm going to go to the alpha area and I need y over x. So that's negative 3/4. Okay. I'm going to go to the beta area and y over x there is negative root of 3 over 3. I'm just going to subtract those two. Now, eventually we'll make this a plus because minus a negative is a plus. Okay, my bottom, I'm going to have 1 plus the negative 3/4 times the negative root of 3 over 3. Okay? Everybody okay with that? Sound good? Okay, let's clean it up. So in the top, I'm going to have negative 3/4 plus root of 3 over 3. In the bottom, I'm going to have 1 plus 3 root of 3 over 12. Okay. Everybody all right there? Okay, now we want to combine the top and we want to combine the bottom. We want one term in the top, one term in the bottom. If you have one term in the top and one term in the bottom, you can do keep, change, flip. If you don't, then you're going to have to multiply by the conjugate. So it's up to you how you do it, but I think we're kind of keep, change, flip seems a little easier to me than having to do all the FOIL with the radicals. So that's what I thought we would do. So, okay, common denominator for 4 and 3 is going to be 12, right? So I'm going to multiply this guy top and bottom by 3. That's going to be negative 9/12 plus multiply this guy by 4 top and bottom. That's 4 root of 3 over 12. Okay. Then down here, I need one chunk. So what am I going to change my 1 to? 12 over 12. Good. So just lots of tedious little algebra. Okay, now we're ready to combine. I'm going to have negative 9 plus 4 root of 3 over 12 all over 12 plus 3 root of 3 over 12. Oh, you're going to have to multiply by the conjugate anyway. We didn't get out of it. Okay. 12s cancel. And we end up with negative 9 plus 4 root of 3 over 12 plus 3 root of 3. Okay. It's a never-ending problem. Are we good so far? All right, now what are we going to multiply top and bottom by? 12 minus 3 root of 3, right? Now we're going to do that. Okay. Seal everybody off. Okay, we're foiling. All right, here we go. Okay, I'm going to have, good gracious, negative 108 plus 27 root of 3 plus 48 root of 3 minus 12. Oh, what is 4 root of 3 times negative 3 root of 3? Well, this is going to give me a negative 12. What's the root of 3 times root of 3 part going to give me? 3. So I'm actually going to have a little minus 36 back here. Everybody okay with that? He's going to be a minus 36. Okay, down here, I'm going to have 144 from the 12 times 12. Now we can skip the middle steps because these are just going to produce terms that cancel. So I can just do 12 times 12, and then I can do the back part, the 3 root of 3 times the negative 3 root of 3, which is going to be a negative 9 times 3, right? That'll be a minus 27 back in there. Okay. Never ending. Here we go. Okay, let's see. So if I have negative 108 minus 36 is negative 144. Then if I do 27 root of 3 plus 48 root of 3, I get 75 root of 3. Then if I do 144 minus 27, I get 117. Now you would think that's it and we can stop, but 117 is one of those things that looks prime. You would bet your life it's prime. It's not prime. It's divisible by 3 and it sneaks into a lot of math problems. So check your triangle, okay? You can actually divide everybody in your triangle by 3. 117 is one of those super weird numbers. Okay, when I divide negative 144 by 3, I get negative 48. When I divide 75 by 3, I get 25. Don't forget his root of 3. And then when I divide 117 by 3, I get 39. That's my final answer. Okay. Whew. All right, let's just talk about the next section because we don't want to get behind. We only got one day left to cover it. So let's just get ready to hit the ground running on Monday. I know that made your hand and brain hurt, okay? All right, is everybody okay with this page if I move it? Okay, all right, so let's talk about this page here for a few minutes. All right, so this kind of puts 176 and 177 like in together. You can see 177 is way the heck back in here and it just has like one page front and back of stuff, that's it. Okay, let's talk about these. So 7.6 talks about double number, or see how this says double angle, this says double number, this says half angle, this says half number. It's one of those things that depending on your textbook, you might call it one thing or another. Your book calls it double number, half number, but when I made these packets, I was thinking about the Stone Ages. When I learned it as double angle, half angle. So sorry, that doesn't really line up, but it's the same thing. Okay, so identities, formulas, whatever you want to call it, but that's what we're going to learn. Okay, so let's look at these. So do you remember, I think it was like in section 7.3, we ran across some things that look like this. Remember that? Where the theta was 2. And what we would do is this is when we were solving equations, we'd have to find the answer for the 2 theta, and then we would have to divide it by 2, and it would give us 4 total answers. You remember that? They were kind of a pain. It's what gave Leighton her breakdown. I don't know if we remember that. Okay, was the double angle? Okay, that's what these are. These are identities or formulas that will prevent you from having to deal with double angles. Because look what happens. It turns double angles into single angles. So you don't actually have to deal with the doubles if you don't want to. okay? Now, why does this say A instead of theta? My math lab, just to try to give you all breakdowns too, will sometimes call it, okay, they use alpha sometimes, they use a capital A sometimes, and sometimes they'll use theta. So depending on what problem you have for section 7.6, they're going to mix and match it all through there for the double and the half. So keep that in mind, okay? Just replace your capital A with alpha or theta, depending on what problem they give you, okay? All right, notice that sine only has one formula that you can use for a double angle. Tangent, one formula you can use for a double angle, that's it. Cosine has like options out the hoo-ha. I mean, look, he's got like 3. You can just pick whichever option you want, which is kind of nice. Because this way, if you want to change it to a cosine sine, you can. If you only want to involve sine, you can. If you only want to involve cosine, you can. You get to pick that. That's your choice based on the problem, whatever suits your problem. And we'll look at that, okay? All right, let's talk about what does a double angle mean? Well, what is cosine theta plus cosine theta? And you're not going to tell me it's cosine 2 theta. What is cosine theta plus cosine theta? 2 cosine theta, right? It's not equal to this, okay? This is just on the angle. This would be the situation where you have, like, for example, let's say theta is 15 degrees. Well, cosine of 15 degrees, or you could make it 2 theta, which would be cosine of 30 degrees. What you're doing is doubling just the angle when you put that 2 there, not the cosine. You're doubling whatever this is. So if this is 15, you're dealing with cosine 30, okay? And then these are gonna half them, okay? We'll talk about that. I wish I had 5 more minutes, but I don't. That's okay. I will see you guys